resistor has the greatest current flowing through it. Okay, so we have problem number 1 and problem number 2. So the first one, use figure 1. Okay, figure 1. A, to arrange from greatest to smallest resistance. B, to arrange from greatest to smallest current flowing through resistors. Okay, so solution A, you have to arrange from greatest to smallest resistance. Okay, using figure 1. So the greatest you have, can you see, 5 ohms. Okay, so R4 is the greatest, greater than. Okay, after 5 ohms you have 3 ohms. Okay, R2, after 3 ohms you have 1.5. Okay, greater than R1. Okay, R1 is equal to 1.5 ohms. Okay, after 1.5 ohms you have 1 ohm. Okay, greater than R5. After 1 ohm you have 0.5 ohm. Okay, R3, greater than R3. Now question B, arrange from greatest to smallest current flowing through the resistors. Okay, so remember, resistance is the same as opposition. Okay, the greater the opposition or the greater the resistance, you are going to have a smaller current flowing through the resistor. So this resistor, which is the greatest among these resistor, it's going to have the smallest current because it's got a higher opposition to the flow of current. So the greater the resistance, the smaller the current flowing through the resistor. So this will have the smallest current and the smallest resistance. Okay, the smallest resistance will have the greatest current. Okay, so this current I3, okay, I3 will be the greatest, followed by I5, greater than I1, greater than I2, greater than I4. Okay, remember, resistance is inversely proportional to the current. The greater the resistance, the smaller the current that is going to flow through the resistor. The smaller the resistance, the greater the current that is going to flow through the resistor. So remember that. Now, problem number 2. Use figure 2 to circle the correct answer. Okay, which resistor has the greatest current flowing through it? Okay, so let me show you. So the current that is coming from the battery is flowing when it reach a splitting point, okay, a junction. Part of the current will flow on this branch, another part of the current will flow on this branch. Okay, you are told, assume that all resistors are equal. Okay, assume that all the resistors are equal. So because the resistors are equal, this current that is coming from the battery will split or divide equally. Okay, so half of the current will flow through this branch, another half will flow through this branch. Okay, so 50% of the current that is coming from the battery will flow on this branch, and 50% of the current that is coming from the battery will flow on this branch. So the value on this resistor is equal to the value on this resistor. This is why the current is going to divide or split equally. So the current will join at this point. Okay, you're going to have 100%, okay, 100% of the current. So this current will split again, okay. Part of the current will flow on this branch, another part will flow on this branch, okay. So you have to convert this, you have to convert the two resistors into one resistor so that you can compare, okay. Remember, you are told all the resistors are equal, okay, they are all identical. So you can change this to R5, okay, R5, and this you also change it to R5, okay, because they are all the same. You want to have R3 and R4 in terms of R5 so that you can compare. So this is a series circuit. They are connected in series. So on this branch, you have two R5, okay, two R5 on this branch, okay, R3 plus R4, okay, total resistance. You have two R5. So you have one R5 on this branch, and on this branch you have two R5. Do you understand? Now you are going to have a greater current on this branch because you have a smaller resistance. On this branch you have two R5. On this branch you are going to have a third of the current, okay, a third of the current, 1/3 of the current. On this branch you are going to have 2/3, okay, 2/3 of the current on this branch because the resistance is smaller. You're going to have 2/3 of the current. The current that is coming from this is going to split. A third will go on this branch and 2/3 will go on this branch. I hope you understand where the 3 is coming. You have 3 parts, okay, 1, 2, 3, 3 parts. So this is the answer. You're going to have 2/3 of the current flowing through R5, okay. On this part you have 2 parts, okay, 1, 2, 2 parts, okay. So I hope you understand. You're going to have R5 having the greatest current flowing through it. Now, which two resistors have the same current flowing through them? Assume that all the resistors are equal. Okay, use figure number 2. So, can you see? Let me raise. The current that is coming from the battery will split equally at this point. Okay, equally, because R1 is equal to R2. Okay, you are told. Okay, so the same current will flow on this branch and the same current will flow on this branch. So the current will join, okay, will join. Now you're going to have the current splitting again. So you have a series connection. You don't have division of current in series connection. So the same current that is flowing through this resistor will come out and will flow through this resistor and then will go out. Okay, same current flowing through R3 and R4. Okay, so which two resistors have the same, okay, the same current flowing through them? Okay, R1 and R2. You also have R3 and R4. Okay, R1 and R2. You also have R3 and R4. Okay, so this is how you can answer this question. Okay, we are done.